Good day and night. Today is going to be a bit of Blender. I've been playing around a bit with how to visualize things and represent things, and I kind of like Blender. And there's one thing in Blender you can't do, and that is animate text. And I wanted to be able to wipe text across the screen and to show it. So this is a 3D text. I can rotate around so we can see this actually 3D text. So I've been playing around with geometry nodes to be able to achieve this effect. And maybe this is interesting to some on how to do this. So previously, before, I'm aware there's the brick modifier, the build modifier. The problem with the build modifier is you have no control over build order. And if we look at the text, we can see it first generates the 2D text, and then it slaps on the 3D elements. And this is not a very nice animation, and I really don't like it. And there's really nothing we can do to control this modifier. We can control the face indexes, but on text objects, that is not possible. And the usual solution is to, well, then convert this to a mesh. The problem is once you convert it to a mesh, you can't modify it anymore. So what people used to do is to create a copy in the background, keep that as a text, convert it to a mesh. And then if you had to edit some text, you would redo the thing. That also applies to curves and all other things. And I don't like that. Now, geometry nodes, they're not that new, but they're new to me. They allow you to take in the geometry of an object and modify it somehow. Right? And this is basically what I'm doing here. I'm going just exploring, just computing basically over the bounding box here from min to max, and that's where I'm wiping from, right? So how does this work? I'm wiping each component separately. All right, so there's this delete geometry node, and if the value, so for every element, if this value here is true, then it will delete that element. That element in this case are vertices, because it's selected as points. And the geometry is the actual geometry of this thing here. And the bounding box, I can... It's not too surprising, but the bounding box, if we actually... That was not supposed to be the output, that was supposed to be the viewer. I can visualize this. It's just the box around the entire object. And as you can see, I've been working on talk about what annoys me about object-oriented programming, and I got sidetracked, and let's not talk about that. Anyway, so that's the bounding box. The min-max is, the min is the bottom left, the max is the top right, because that's the Blender coordinate system. The negatives are down, left, and forward, I believe. No, backwards, right? No, forward. Yeah. Okay. I had it right the first time. Okay, so how does this work? Basically, they're Boolean, so let's just imagine this magically selects them somehow. We're gonna look at how this works in a second. It takes in the if we're wiping across X and if we flip the direction. So let me quickly show what flipping does. So if I flip the direction of X, then we're wiping across the other direction, right? If I had X before, right? Right, so if the X wipe deletes this vertex, or the Y wipe deletes the vertex, or the Z wipe deletes the vertex, then we're going to delete it. So if any of those filters hit, we're going to delete the point. So how does a point actually work? So we're going to take the vector and we're going to split it by the x components, because this is the x wipe, it only cares about the x component, right? And then we're going to subtract the maximum value, the minimum value from the maximum value. And what that does is get us the length of the bounding box. So once we have the length, we can multiply that with the wipe position between 0 and 1. Let me actually just put up paint, and that will demonstrate better what we're doing here. So if we imagine this as the bar that we have, and we have some sort of position here, and we want to display the these here. That's what we want to show. Then what we really need to do is we need to delete these here. And if min is here and max is here, then we can compute this position by adding to min the length here, whatever this is, and that is max minus min times the position in percent, right? Times pos. That computation is what we're seeing, and then we're going to check everything that is greater than this is over here, and that's what we want to delete. In the non-flipped case. In the flipped case, we actually want to do the exact other thing. We want to subtract from max to the position and delete on the other side. So this subtract gets us the length, and this multiply gets us the actual position scaled by the wipe position. And then we're just going to add the minimum to the minimum x, this multiply here. And that is what this node does. So that gets us the position we just talked about. Now we have this point. Then we're going to check it if it's greater than the individual position of a point. So this is the position per point. We're also getting the x coordinate from that. And then checking if that coordinate is greater than this one. That selects these here. And then there's some Boolean logic here to control the direction and if it's selected. So basically here, if we're flipping it, then we don't want to use this path. We're going to use the other calculation path on top. So if flip is not selected, then this is true. So true and true activates this node. So we are activating this output path with that. And then if we're actively actually using this node here, that activates the output of this entire thing. Yep. I could have put it down here, behind here as well. First or and then and, but it doesn't make a difference. So if we're also activated on X, then we're outputting. Yep. And this or just combines the paths here. And this here is a bit of a hack if we don't do that. We can see here actually it's easier to show on the Z wipe. So if we don't do this and we say this is always true, and we're going to activate the Z, and we're going to go all the way to 1. We can see the front faces are missing. And that is because we're checking greater than. So we basically have a choice between at 0 we're going to display the first vertex, or at 1 we're not going to display the final vertex. And that's what this does. It fixes this, because it just checks if it's 1. If it's 1, we are going to override and always display. So if I go back and fix this, we can see it's going to display that thing actually now, right? And that's the bottom path. The top path is the exact same, except we're going, we're starting instead of from on the min, we're starting on the max. The length calculation is exactly the same, and then we're just subtracting from the max the length, which gives us this position. And then the rest is the same, except we're going less than or equal. We are also activating, we're not flipping the knot because we want to have them actually opposite to each other, so we can plug it in directly, and the rest is literally the same. All three nodes look identical. The only difference is which component they're selecting. So if they're selecting X, Y, or Z. And that is really it. There's certainly some things to clean up in here. Maybe this is interesting, maybe not. If you like my random content, feel free to subscribe, join my Discord, and have a good day or night.